You picture a hunter crouched behind a rock, spear in hand, waiting for a mammoth to wander into range. That image has sold 1,000 diet books. Steak for breakfast. No bread, ever. The logic sounds airtight. Your ancestors were hunters, so meat was the point. It's also almost completely wrong. For most of the last million years, the animal you were chasing was the least reliable meal on the table. What actually kept early humans alive, generation after generation, was something far less cinematic and far more interesting. Start with a site on the shore of an ancient lake in what is now northern Israel. Around 780,000 years ago, at a place called Gesher Benot Ya'akov, groups of early humans sat beside the water with basalt tools in their hands. Archaeologists studying those tools decades later noticed something odd stuck to the surface: microscopic starch grains, preserved in the cracks of the stone for 750,000 years. When researchers analyzed them, they found the residue of acorns, wild cereal grains, legumes, and even water lilies and a now extinct type of water chestnut pulled from the lake itself. These were not accidental scraps caught on a tool used for something else. The wear patterns on the stone showed deliberate, repeated pounding and grinding, the exact motion you'd use to crack open a nut or crush a fibrous root into something edible. This is nearly 750,000 years before agriculture existed anywhere on Earth. And already, plants weren't a backup plan. They were the plan. So why does the meat-heavy story dominate every documentary and every diet trend? Partly, it's a problem of what survives. Bury a mammoth bone in the ground and, under the right conditions, it can last for 100,000 years. Bury a handful of crushed acorns, and within a season it's gone, broken down by soil, insects, and time. Archaeologists spent most of the 20th century digging up sites full of animal bones and drawing the obvious conclusion: these people ate meat, because that's what was left to find. Plants simply didn't leave a trace, so for decades, they didn't leave an impression either. That started to change once researchers began looking somewhere other than the trash pile. They started looking at teeth. Dental plaque, the same sticky film your dentist scrapes off today, hardens over a lifetime into a substance called calculus, and it traps microscopic evidence of whatever passed through your mouth. Researchers studying calculus on human teeth from sites across East Asia, dated between 120,000 and 80,000 years old, recovered starch grains from acorns, wild tubers, and grass seeds directly from the plaque itself. Not from a tool. From the meal. This wasn't circumstantial evidence anymore. It was a molecular record of what someone actually chewed. A 2026 study published in the Journal of Archaeological Research, led by researchers at the Australian National University and the University of Toronto Mississauga, pulled this thread even further, and it directly challenges an idea anthropologists have taught for over 50 years. In 1969, archaeologist Kent Flannery proposed what became known as the broad-spectrum revolution, the theory that early humans hunted big game almost exclusively until relatively late in prehistory, only branching out into smaller animals, fish, and plants once large prey became scarce. This new research found the opposite pattern stretching back hundreds of thousands of years earlier than Flannery's timeline. Plant processing wasn't a late-stage adaptation forced by desperation. It ran alongside hunting the entire time, in Neanderthals, in early Homo sapiens, and in species older than both. Now picture something a little more uncomfortable: a set of teeth from Morocco, roughly 15,000 years old, belonging to a population called the Ibero-Maurusians, unearthed at a site called Tafrelt. These teeth had cavities. A lot of them, far more than you'd expect from a typical hunter-gatherer population of that era. Cavities happen when bacteria feed on fermentable carbohydrates trapped between your teeth, exactly the kind of environment created by a diet heavy in starchy plants like wild cereals or ground acorns, especially if those foods were stored, sprouted, or lightly fermented before eating. In other words, the closest thing to hard proof of eating too many carbs you'll find anywhere in the fossil record, tens of thousands of years before anyone planted a single seed on purpose. So picture the actual scene. Not a hunter alone behind a rock. A group, moving through a season. In spring, you gather shoots and greens as they emerge, plus eggs if you can find a nest. In summer, fruit ripens and you follow it, along with fish if you're near water. In autumn, nuts fall in enormous quantities, and this is when serious processing happens: cracking, grinding, leaching out bitterness, storing what you can for leaner months ahead. Winter is when hunting becomes most essential, because plant food is scarcest and stored calories are running low. Meat mattered enormously. It's calorie dense, packed with fat and protein your body needs, and a successful hunt could feed a group for days. But it was never a daily guarantee. Plants were the daily guarantee. Reliable, gatherable by nearly anyone in the group including children and elders, and, crucially, a steady source of the carbohydrates your unusually large, energy-hungry brain runs on. Here's the twist that should reframe everything: cooking, not hunting, might be the real hinge point in human evolutionary history. Raw starchy plants are hard to digest. Much of their caloric value passes straight through your gut, locked inside cell walls your body can't break down on its own. Cooking changes that completely. Experiments measuring digestibility have found that cooking starchy foods can increase the calories your small intestine actually extracts by anywhere from 28 to over 100%, depending on the food. Across starches, proteins, and fats combined, a reasonable estimate puts the net gain from cooking at roughly 30% more usable energy from the same amount of food. That's not a minor convenience. That's potentially the difference that allowed a calorie-expensive, oversized brain to evolve in the first place. The exact date humans mastered fire is still debated, but solid archaeological evidence for regular, controlled fire use goes back at least 400,000 years, possibly further. Every time you picture a Paleolithic scene with a fire crackling at its center, that fire wasn't just for warmth or safety from predators. It was, quite possibly, the single most important kitchen appliance in the entire history of your species. So the next time you see a diet promising to recreate what your ancestors ate, notice what it usually leaves out: the acorns, the wild grains, the roasted tubers, the honey, the starchy roots dug up and cooked over the exact fire that made your oversized brain affordable to run in the first place. You picture a hunter crouched behind a rock, spear in hand, waiting. But just as often, if you rewind far enough, you'd find someone else entirely, crouched by a fire instead, cracking open a pile of acorns gathered that morning, grinding roots into something soft enough to eat, quietly doing the less glamorous work that, more than any single hunt, kept the whole group alive.